First thing you see is a cumulus form, and usually the first indication that's on satellite. Shortly after that, you see the echo on radar where it starts to precipitate. The storm didn't take long before it grew very rapidly, got very tall very quickly, and with the wind fields that were in place that day, the radar was showing that, almost immediately that we had a rotating updraft, and quickly turned into a supercell thunderstorm. 20 to 30 minutes after we saw the first echo, we issued a severe thunderstorm. So we knew, it was a significant storm even at that point. As it got closer to Chickasha, that rotation within the storm had tightened up and had gotten a lot stronger. And that's when we issued the tornado warning. And shortly thereafter is when we had the first reports of a tornado to the southwest of Chickasha. We had no idea that it was going to turn into what it did later that evening.
It was apparent that this was a very well organized supercell thunderstorm. It was prolific at tornado production. Every tornado seemed to be getting larger as time went on, and one only had to look at the map and the path that it was on. It would be difficult to imagine that storm, one, weakening, and two, not impacting severely some highly populated parts of central Oklahoma. We had one television. It was kind of mounted from the ceiling up in the corner. We'd switch it from station to station from time to time, trying to get some pictures, what the tornadoes looked like, some of the impacts in terms of damage, how bad is it. Hearing something is not the same as seeing something. Most of the contact occurred as the event was happening, and that would be with law enforcement, folks like the Highway Patrol and local law enforcement personnel, other Weather Service offices, because as the storm was moving into Grady County, there was some concern that it might turn slightly and move into Norman, which would affect our ability to do our jobs. If we lost all of our communications and electrical power and things of that sort became affected, then we would have to have our sister office, which is Tulsa, assume the warning responsibility for central and western Oklahoma and part of North Texas.
A lot of people asked me after the fact that they said, "Man, it must have been just crazy in that office with that event going on." And I tell them, it wasn't crazy at all. I said everybody was so calm, so collected, knew exactly what their job was, and did it expertly. Just was really efficient, really was done really well. I said it wasn't crazy at all. You'd be surprised at how quiet the office was during that whole event.
My day started in the office around 8 o'clock, and I probably left around 1 or 1:30 the following morning. And then because we still had ongoing severe weather and then dealing with the aftermath of what had happened, I came back around 7 a.m. and we started in again. And
that's when it got crazy in the office, was the next day after. We're still dealing with severe weather the next morning, but then of course we've got all the local, all the national, all the international news media calling. We've got teams of people coming in to try to go out and do a lot of damage surveys and try to evaluate things like that. And so the next day was chaotic because of that, but not because of the weather.
It's clearly a standout event. It's an order of magnitude bigger in terms of the number of strong and violent tornadoes, the prolific nature of the storms at producing tornadoes. Any one of those storms would have been a significant, memorable storm on another day. And to have had so many of them in such a short time span is really unprecedented in my career, although I know these things can happen from time to time. I had not experienced one myself.
We see thunderstorms of that nature, that are similar to that quite often. But, in our science, it's hard to say, which one of those storms, why did this storm not produce when this one did? I think a lot of study is still going into that. There's a lot of learning to try to figure out what in particular happened with that thunderstorm that allowed that to produce that kind of tornado that stayed on the ground that long. Usually, even if we see a thunderstorm that'll produce a tornado like that, it won't stay on the ground that long.
As far as what we took away from that and changed, I think that We had some strategies for how to cope with so many storms and how to configure our computer workstations to handle the load of data and information, and we were able to share that with other offices in the Weather Service, and I think we had some influence about how severe weather events might be handled in other parts of the country now.
A lot of the tools we have changed, they've evolved. I think some of that probably because of the events of May 3rd. We've seen quite a bit of change in not only model forecasting and how well they do. I mean, we run a local model here every hour that we can it actually will forecast what the radar is going to look like in the coming hours. So we can kind of get an idea maybe if convection is going to get started based on those high resolution model data that we didn't have before. We've got different types of radar in place now across the state that we didn't have 10 years ago. That gives us more data, quicker data, things of that nature. So there's been a lot of changes that have occurred that that we have to adapt to, how to learn how to use, and then allows us to do a better job than we did, and maybe even then.